And here is our formula if events are not disjoint. That is, if two or more events can happen at the same time, we need a slightly different formula for finding the probability. So here it is. If events A and B are not disjoint, then the probability that either event A or event B happens is equal to the probability that the first event happens plus the probability that the second event happens. So far, that's the same as our first formula. But then here, we have to back out. We have to subtract the probability that both of them do happen at the same time. And our example here that we just did was the King of Hearts, was where both we had a king and a heart. Okay, so let's keep this idea in mind that we have to subtract out anything that in which they're happening at the same time if they're not disjoint. So let's do a couple examples. Okay, let's say you go to a pet store and you want to buy a pet. You just can't decide on what kind of pet you want, so you ask the store owner to place the rabbits and cats and hamsters all together in one big pen, and there are 16 animals, and you're going to just close your eyes and randomly reach in and pull out an animal. I hope that doesn't bite you in the process, but that's what we're going to do. So in the pen of the 16 animals, we have 2 brown rabbits and 3 white rabbits, 1 black cat, 3 white cats, 5 brown hamsters, and 2 white hamsters. Okay, let's do some probability, starting with some pretty simple ones. Okay, you may want to write this down because this is going to slowly move out of view. Now, once again, we're performing one trial. That is, we're going to randomly choose one animal that's in the pen. So the probability that we get a white hamster, well, of the 16 animals, 2 of the animals were white hamsters. So the probability that I get a white hamster is 2 out of 16, which reduces to 1/8. If you want to write it as a decimal, that'd be 0.125. Once again, we always round our decimals to 3 significant digits. Let's try this probability. The probability that we reach in and we get a white animal. Well, all the white animals are the 3 white rabbits, the 3 white cats, and the 2 white hamsters. That's a total of 8 white animals out of the total of 16. So the probability of getting a white animal is 8 out of 16, which of course reduces to 0.5 or 1/2. Now, what's the probability that I get a white animal or a brown animal? Now we're doing an event that is made up of 2 possible outcomes. And before we can do this problem, we need to stop and think, are these 2 outcomes disjoint or not? Can they happen at the same time, or they cannot happen at the same time? Can an animal be white and at the same time be brown? And at least for these 16 animals, that answer is no, they cannot happen at the same time, so they are disjoint events, disjoint outcomes. So we use the simpler formula to find the probability that we get a white animal or brown animal is just the probability of getting a white animal plus the probability of getting a brown animal. And the probability we get a white one, we already know, is 8 out of 16. The probability of getting a brown animal is, well, we had 2 brown rabbits and 5 brown hamsters, a total of 7. So that is plus 7 out of 16, which is a total of 15 out of 16. Okay, let's go one step further. What's the probability that we would get a hamster or a brown animal? Once again, we've got to ask ourselves, are these 2 outcomes disjoint events? Can they occur at the same time or not? Is it possible to get a hamster that is brown animal? That is a brown animal. And the answer, of course, is yes, right here. We have 5 such of those. So we know these are not disjoint events. So I've got to use the more complicated formula in which we have to back out what is common. So here we go. The probability is equal to the probability of getting a hamster, and altogether there are 7 hamsters, so that's 7 out of 16. There are 7 brown animals, that's 7 out of the 16 of brown animals, but we know we have counted the 5 brown hamsters in both of these, so we have to back out the 5 brown hamsters that have been counted twice, so that's 14 minus 5, that's 9/16. Or if you like, you can change that to a decimal rounded to 3 significant digits. Let's do one more from the pet store. What's the probability that we reach in one time and pull out either a cat or a white animal? Well, once again, are these two outcomes disjoint? And the answer is no. They can happen at the same time. Namely, we can get a white cat. It can happen 3 times. So we'll have to back this out because we know we're going to be counting them twice. So the probability of getting a cat is, well, there's 4 cats altogether. That's 4 out of 16. The probability of getting a white animal, we counted that earlier as being 8 out of 16. But we've counted these 3 white cats twice. So we have to back out one of those, groups of 3. So that adds up to 12/16 minus 3/16, which again happens to be 9/16. I'd like to do one more example. Here's the situation. We have a party. There are 25 men at the party. 19 of these men are bald. 8 of these men wear glasses. And 5 of the men are both bald and wear glasses. Now, if we are going to randomly choose one of these 25 men, what's the probability that the one that is chosen is either bald or wears glasses? Well, that should be pretty straightforward now. The question is, are these 2 events disjoint? And the answer is no, they're not disjoint. They can happen at the same time. We have some men that are both bald and wear glasses. So we know we're going to have to back out what is common. So here we go. The probability of getting a man that is bald is 19 out of 25. The probability of getting a man who wears glasses, since there are 8 of them, that's 8 out of 25. But we know we've counted some men twice in this fraction and in this fraction, namely those 5 men that are both bald and wear glasses. So we have to back that out because we don't want to count them twice. So 19 plus 8 is 27, minus 5 is 22/25, which is equal to, as a decimal, 0.88, or if you want it to 3 decimal places, 0.880, which is 88% chance of getting a man that is either bald or wears glasses. What's the probability of getting a man that is neither bald nor wearing glasses? Well, then it's just the complement of my answer here, 88%, which is 12% chance that we get a man that is neither bald nor wearing glasses. All right, that wraps up our discussion of figuring probabilities when we're performing one trial of a well-defined random procedure.